Hello, this is Akshay with another video here, and this time around the video is going to focus on whatever you have learned in concepts here that's gonna be applicable, and the best way to apply the concept is numerical problem. So let us start to take on the numerical problem here. Let me tell you, it's coming from the series combination and we are going to check it out very soon here. So this is the numerical and electric lamp. Here it is electric lamp whose resistance is 20 ohm. It is already mentioned here, that is R1 is 20 ohm, and a conductor, this is a conductor having resistance 4 ohm. I have taken it as a R2 is equal to 4 ohm, are connected to a 6 volt battery. This is the voltage, that is 6 volt. Both are connected to 6 volt battery, and these are the arrays of questions being asked here. That is, yes, the total resistance of the circuit, you have to find out what's the net resistance in this very circuit, that is the total. Number 2, you have to find out the total current flowing through this very circuit, and number 3 is the potential difference acting across electric lamp. It is how much potential difference is acting across electric lamp. That's what we are going to find out here. Here it is. Since the resistor is R1, we are going to take it as V1. That is the potential difference we are going to find out acting across R1, that is electric lamp, and the potential difference acting across the conductor. Since conductor having resistance R2, it means we are going to take it as V2. Okay, B2. In such kind of a numerical problem, first things first, that is, just try to understand what nature this numerical belongs to, which whether it is belonging to the series combination or parallel combination or mixed combination. So this is where your definitions are gonna be handy. We know end-to-end combination is called series combination. You can see here, never ever it has been mentioned in this very numerical problem. Nowhere it has been mentioned that is whether it is a series combination or a parallel combination or a mixed combination. It's up to you to decide that is which combination this numerical problem belongs to. Once you know the nature of the, you can say, combination, you would be in you would be on the right way to crack this very numerical problem in the easiest possible manner there. So since end-to-end combination it is, how can we summarize it? Just this way. Here the one end of the R2 resistor is being connected to the one end of the R1 resistor. This is the end-to-end combination. And what about the other ends or remaining ends of these two resistors? The remaining end, this one end is connected to the positive terminal of the battery, and the remaining end of this very electric bulb is connected to the negative terminal of the battery. So that tells us that this combination is a series combination. Once you understand the nature of the combination, all the, you can say, that is facts related to that very combination are gonna play a vital role in cracking such kind of numerical problems here. So firstly, total resistance of the circuit we are going to find out. You have made your mind that is it is a series combination, and in series combination total resistance or the resultant resistance is always equal to the sum of individual resistances. So here it is A part, total resistance we are going to find out, and total resistance it is RS. That's going for a question mark. We have got R1, it is 20 ohm. We have already got R2, it is 4 ohm. 4 ohm, and RS is equal to arithmetic sum of individual resistances, and it is R1 plus R2. Here this combination is in series. It is series combination. You can put the reason behind it, series combination, or therefore total resistance RS is equal to R1 plus R2. R1 it is 20 and R2 it is 4 and it is ohm, and RS is equal to 24 ohm. That's one. First total resistance we have got, it is 24 ohm. Now we are going to come across the second part, that is the B part here. That is, yes, the total current through the circuit. Total current, that is I current you have to find out. When it is being talked about total current, it means everything should be in total. everything should be in total. And we are going to apply a triangle technique here, and you are well familiar with triangle technique, VIR. So total current is needed, it means total voltage is required and the total resistance is required. We got the total resistance, this is the total resistance 24 ohm. We know the total voltage is 6 volt, and hence we will apply this very formula, that is total current I is equal to V upon R. So here total current I, this is what we want to calculate. Total resistance, how much it is, RS, that is total resistance, it is 24 ohm, we have calculated a bit earlier. And the total voltage, it is V, and it is given, that is 6 volt. So therefore I is equal to V upon RS. So here by using Ohm's law, we want to find our total current, that is I, and it is I is equal to V upon RS, total resistance, total voltage, or I is equal to, how much V is 6 volt and RS is 24 ohm, 24 ohm, and 6 ones are 6 and it is 4, and therefore total current I is equal to 0.25 ampere. That's the second part. Total current we have got, that is I, here it is I, and it is 0.25 ampere. It is. Now come to the final point here, that is the C part. And in C part, what is being asked here? Potential difference across the electric lamp. The potential difference across the conductor. It means across the electric lamp we have taken V1. We want to find out V1, and across the across the conductor, the potential difference is being considered as V2. That's question mark. Okay, now these are easy to find out because you know the nature of this very resistor. But we are knowing that this is the technique we are going to put into play here. That is Ohm's law, triangle technique. We know that is the resistance. Firstly, we will find out voltage V1, that the voltage acting across the electric bulb. This is what required, and thereafter we will find out V2. You know why this question is valid, because of the reason that this combination is in series, and in series combination voltage got distributed V1 and V2, and we are going to find out what is V1 and what is V2. And V1, in order to find out V1, but we are required I and R, means what is the resistance of R1 and what amount of the current flowing through R1. Resistance is 20 ohm and the current will be 0.25 ampere. Why? Because this combination is in series, and hence the total current will flow through each and every resistor. Since the total current is 0.25 ampere, it means 0.25 ampere current will flow through R2. It will flow through R1. So we know 0.25 ampere current is flowing through 20 ohm resistor. So therefore, by applying or by using Ohm's law, and what the formula is going to be, V1 we want to find out, it is V1. Current total, here it is the total current will flow through each and every resistor in series combination, and R has become R1. So formula will come out to be, that is V1 is equal to IR1. Okay, or V1 is equal to I, it is 0.25 ampere. You have calculated already. But is R1, R1 is 20 ohm, and multiply both these two and we will get, therefore V1, that is potential difference acting across R1, V1 is equal to, multiply it and you will get 5 volt. This is 5 volt. 5 volt potential difference is acting across R1, 5 volt. Okay, now we are going to find out what is V2. Remember, it is going to be 1 volt. Why? Because in series combination, that's where the concept is going to be applicable. In series combination, you have learnt that the total voltage is going to be distributed among the number of resistors. Since we have got mathematically that this resistor is getting 5 volt out of 6 volt, then how much volt has been left? 1 volt, and 1 volt is being received by R2. So that makes 1 volt plus 5 volt equals to 6 volt. Anyway, we will find it mathematically. So here it is, we are going for V2. So V2, it means it is V2. I remain the same because total current will flow through each and every resistor. Thanks to the series combination, it is. I remain the same, but is R. R has become R2. It is V2, it is R2, and it is I. So here it is. We will write once again by using Ohm's law. V2, now it is what we are going to calculate. V2 is equal to I, here it is I and R2, the product of I and R2, or V2 is equal to, how much I we have got? 0.25 ampere multiplied by R2, it is 4 ohm. Multiply these two and you will get, therefore V2 is equal to 1 volt. So V2 is equal to 1 volt. Here it is 1 volt, here it is 5 volt. Add them and you will get 6 volt, and that makes sense. Then we have learnt in series combination that the total voltage in series combination is gonna be distributed among the number of resistors. Since there are only 2 resistors, one resistor is getting 5 volt, it is quite clear that the another resistor will get 1 volt, and that's what you have got. V2 is equal to 1 volt, and that's how you are gonna just crack such kind of a numerical, thanks to the conceptual clarity you have already got in your mind. That's it here.